The standard engine uses a single engine oil cooler mounted in the driver's side fender well, while the high power gets a second mounted on the passenger side. Oil output is regulated by the metering oil pump and PCM based on engine RPM, engine coolant temperature, and the amount of intake air. After 12 key cycles, when the ignition is turned off, the PCM activates the main relay so the metering oil pump can perform a switch test to confirm proper operation. Each rotor housing has a pair of oil injectors aimed toward the intermediate and side housings. Inside the engine, special cast iron apex seals have been processed with electronic beams to improve abrasion resistance. The apex seals sweep the trochoid surface of the rotor housings, maintaining a gas seal with the combination of two apex seal springs, side seals, and the centrifugal force of the rotor in motion. Keystone-shaped side seals have been added to help scrape away carbon from the seal area. When the rotor is at top dead center of exhaust, all intake and exhaust ports are closed. However, there is still a small gap between the rotor and the side housings, which could allow exhaust gas to flow into the intake port. To prevent this, a cutoff seal has been added between the oil seals and the side seals. WDS can be used to perform a compression test on the Renesas engine using this special service tool. Disable the ignition system by carefully disconnecting the eccentric shaft position sensor connector. Connect one end of the compression test adapter to the front rotor trailing spark plug hole. Connect the other end to the WDS vacuum pressure transducer. From the WDS toolbox, choose Compression Test. Hold the throttle wide open and crank the engine. The WDS will display the compression specification and cranking speed for rotor number 1. Repeat the test on rotor number 2 and compare the test results to determine engine condition. For improved emission control, the front heated oxygen sensor is now a current measuring sensor, rather than a conventional voltage measuring sensor. Current measuring provides for much closer control of the air-fuel ratio, improving fuel economy and reducing emissions. The PCM sends a 2.9 volt reference signal to the front O2 sensor. The O2 sensor varies its output in hundredths of a volt based on oxygen content and returns it to the PCM. This hundredth of a volt change is converted to milliamps by the PCM. This makes comparisons to conventional O2 sensor switching voltages obsolete. WDS O2S11 PID data will display as a milliamp value. For improved cold start emissions, the RX-8 uses an electric secondary air pump to inject air into the exhaust for approximately 1 minute after cold start, or until the catalytic converter reaches operating temperature. The catalytic converter consists of a 3-way platinum-palladium-rhodium-based catalyst. The rear oxygen sensor is housed in the catalytic converter and monitors catalyst efficiency. It is a conventional voltage-sensing O2 sensor. The RX-8 uses a pressure-based EVAP system, which is similar to the Mazda 6 and 2003 MPV and Miata. The charcoal canister and pump are located at the rear of the vehicle, near the fuel tank, above the rear suspension cradle. The purge control solenoid and catch tank are an integral part of the upper intake manifold. When the ignition is turned off, the main relay is energized, and the EVAP pump will perform a leak test the second time these conditions are met. Vehicle was started after a cold soak of at least 5 hours. Vehicle was driven at least 10 minutes and the ignition turned off. intake air temperature between 50 and 140 degrees Fahrenheit, battery voltage between 11 and 14.5 volts, atmospheric pressure above 21.33 inches of mercury, and the fuel level is between 15 and 85%. WDS can also be used to perform the evap leak test and check Mode 6 data. Like the Mazda 6, the RX-8 uses a Controller Area Network, or CAN, to communicate between modules. CAN links together the instrument cluster, ABS, dynamic stability control, and electronic power steering control units, SAS control module, tire pressure monitoring system, PCM, and the TCM on vehicles equipped with an automatic transmission. The CAN high-speed multiplex network enables many onboard diagnostic features to be accessed using the WDS.